Cool. Yeah, I think that's going to work.
Alrighty, everybody ready? Okay, we're going to start learning some processing. So, first of all, how many people here have heard of coordinate geometry? Did you do it in primary school, secondary school? How many people have never heard of coordinate geometry? Anybody? I bet you have. When I show it to you, you'll probably have heard of it. Maybe just know it by a different term, right? So the first thing that I'm going to explain to you, you're going to know this, right? It's very obvious. So you're used to this idea of the number line, yeah, and the x and y axes and things. Okay, so processing is the same as most graphics frameworks in that the origin, in other words, the 0 position, is in the top left-hand corner as opposed to the bottom left-hand corner. So when you're doing x and y axes, you know, in school and stuff, you're used to putting the x-axis this way and the x-axis this way, and then the y-axis this way. A, x, y, s, like that, yeah? It works slightly differently in processing. And in processing, this is the x-axis here, and then this is the y-axis. So this has kind of profound difference and profound implication for how we do certain types of calculations, like calculating angles. But anyway, that's the x-axis goes this way. This is the positive x-axis, and this is the positive y-axis that way. And then this is the negative x-axis, negative y-axis that way, off the top of the screen. Is that okay with everybody? If I pick a point in this 2D space, I can specify any point using coordinates, two numbers. And say I pick this number here. This number might be 5 and say 3. Okay, so that means 5 units across on the x-axis and 3 units down from the on the y-axis. The first number tells you what? How far away you are from the y-axis. And the second number tells you how far away you are from the x-axis. Alright, so you count the distance out and then that gives you the point. So then we have 2 points like this. So say that point there could be over 15 and down 10. Alright, so I've now specified 2 points using coordinate geometry. Is that okay with everybody? Everybody understand how coordinates work? So 2 numbers we give, which is the x number and the y number, and then that gives us the location of a point in 2D space. That's pretty hopefully alright with everybody. Is that okay? So, okay, we've got some processing commands here. This is the processing IDE. And the processing IDE is a very, very simple IDE. There's no debugger, for example. So when we start using Java in Eclipse, we'll use a debugger. And when you write quite complex programs, it's very hard to write them without the use of a debugger. But processing doesn't have one. It's very simple. You start up the processing IDE, you've got 2 buttons up in the left there. The first button is the play button, and that will run your program. And the second button is the stop button. Processing programs are not called programs, they're called sketches. And they're called sketches because typically a processing program will always draw something. So we're going to write our hello world in processing. So hello world typically is going to print hello world on the screen. We'll do a different thing in processing. We'll do a little drawing. And here's the first processing command we're going to learn. Line. Okay, so I'll zoom in so you can see that a bit better. Can everybody see that? So that's our first processing statement. So if you have processing there, you can type that in. Okay, so line, what do you think it does? Oh, you guys are really smart. Yeah, it draws a line, okay? It takes 4 numbers to draw the line. What do you think the 4 numbers mean? They're 2 sets of coordinates. So the first set of coordinates are the x1, y1, and then the second set of coordinates are the x2, y2. Alright, so we've got 2 points specified. So that's going to draw a point. What way will that line, what's it going to look like before we even run it? It will be a diagonal line. Alright, so we're going to start at over 10, down 10, and then we're going to go over 50 and down 50, and we'll draw our line like that. So it'll look like a diagonal line. So, let's do it. Let's click the play button and see what happens. This is very exciting. Our first processing sketch. Oh my god. A line. We got a line and we got a processing sketch. This is great. What's that?
What's the x and y to?
The first parameter is x1, and then the second parameter is the y1, and then it's x2 and y2. So that's x, y, x, y. So that's over 10 and down 10, and then over 50 and down 50. Okay, and those coordinates are specified relative to the origin. So the second set of coordinates are not offsets, they're relative to the origin. They're absolute positions in 2D space.
Zero.
What's that?
50 relative to 0.
Yeah, 50-50 is relative to 0. Yeah. Yeah, so they're not offsets. Some of them are offsets when you use processing sketches. The parameters mean different things. Just in terms of programming, what would you call that? I mean, in terms of programming, what have we just done? We have called a function. Alright, so there's a function called line which draws a line. And that's calling a function with 4 parameters. So you notice the syntax of this is the same syntax as the C programming language that you learned in first year. Is that okay? We're going to do our next processing command, right? Our next processing command we will use is ellipse. So this statement, let's specify some coordinates, some parameters for this. Let's go 25, 25, and let's do 10 and 10. So first of all, what's an ellipse? It's an oval shape, or a circle. Alright, so it's something that's basically round. What do you think the parameters mean for the ellipse? The first two?
The origin.
They're the center point. Alright, so when you type ellipse in processing, the first 2 parameters are the center point. The next 2 parameters, the width and the height. Very good. So that's going to draw an ellipse. And what type of ellipse is that? It's a circle, because the width and the height are the same. Is that alright with everybody? So we'll run it. And so there we go, a little ellipse drawn at position 25, 25, and you can see that it's of radius 10. So we can just try, oh yeah, you just click play and stop and it will run your processing sketch and stop your processing sketch there. So
Which is the radius?
the 2 last parameters are the radius. So that's actually the width and the height of the ellipse. If you want something of radius 10, what would you specify for the width and the height? You would specify, if you want something of radius 10, you would specify 20, yeah, because it's the width is from here to here, and you want half of that, which is the radius. Does everybody understand that? Think about that for a second, will you, before we move on. That's the width, which is the total thing, so the radius will be half that. If you wanted something of radius 10, you would specify a width of 20. So you can do, for example, just to show you that it's an oval shape, you can specify a width of 30 and a height of 10, and you're going to get this kind of shape. So you can see now it's an ellipse shape. You know, it's clearly not a circle anymore. And that's got a different width than its height.
So if you put that function before lines, would
Yeah.
the line be on top of the circle?
Great question. The great thing about processing is anything like that you're not sure about, just try it and see what happens. Here we go. So what have we learned? What fundamental principle of programming have we learned by that? Great question. Huh? Yeah, we learned the principle that I'm sure Michael probably talked about in first year, principle of sequence. You know, the three sort of fundamental pillars of what we call procedural programming. Sequence, selection, and the third one? What's that? Dynamic? Yeah, what do you mean by that?
Well,
No problems, no problems. Does anyone know what the 3 principles of procedural programming are? Sequence, selection, and what are the things that we can do? We can do things one after another. We can make decisions in our programming, and we can also... We can what?
Input output.
Yeah, sure, that's just sequence. They're just things that we do in a sequence. The third thing that computer programs do, they're great at it. Huh?
Modifying sets.
Sure, I think that's probably sequence, yeah? We're just doing things in a sequence.
Function.
Calculating is all sequence. Loops. What are loops? What's the programming term for a loop?
oh, recursive.
What's that? Iteration. Alright, so sequence, selection, iteration. Okay, so we've just learned about sequence by writing 2 statements in processing. That the computer executes the instructions one after another. And it does them in the order in which you write the program. Does everybody get that? That's sequence, alright? So you can understand sequence straight away. So anyway, we've got line, we've got ellipse. Let's do the next one. What are the shape point we want to draw?
Triangle. Square.
Triangle. There is a statement for triangle as far as I know. When it turns up blue like that, that means it's built into the language. So there is a statement for triangle, and I actually, you know what? I never used this. I've never used it before. But let's see if we can figure out what the parameters. How many parameters would you say it would take? I think 6 probably. And what are the 6 going to be? Yeah, the coordinates of the vertices of the triangle. Let's try it out and see what happens. Let's specify 0, 0 for the first parameter. Interestingly, what's the type of those parameters, would you say? Are they floats, ints, strings, characters?
It could be ints, but you say them stuff that you need.
Yeah, I think they're probably ints, but I actually need to look it up. Yeah, ints because they're actually absolute positions on the screen. So, you know, each pixel, do you know what a pixel is? So a pixel, can somebody give me a definition for a pixel? A dot on the screen. Yeah, what does pixel stand for? What's it short for? It's short for something. Huh?
Picture element.
Picture element. Yeah, it's short for pixel, picture element. So it's actually just a coordinate. A point is a pixel. So we'll try something here. Let's try 100, 100, and let's try 50, 50. And we'll see this program run. Hopefully, if it does, we'll get a track.
It's going to be a line.
Oh yeah, that's going to be a line, isn't it? You're right, that will be just a line because they're all diagonal. Okay, so there we go. We've got triangle. So we got ellipse, line, triangle.
So what would each of them coordinates be?
They're the coordinates of the vertices of the triangle.
Which set? Is it like each corner?
It actually doesn't matter.
What's each corner? Is it?
Yes, exactly, each corner. And we call a corner of a triangle, we call it a vertex. So it'll be the corners of the vertices of the triangle. By the way, I want everybody to feel very comfortable asking questions in this class. Alright, so if there's something I say that you don't understand, then please interrupt me and ask a question straight away. Don't wait until the end of the class to go up onto boards.ie and say, I hadn't a clue what that guy was talking about. He's a terrible lecturer. No, just take the time and take responsibility if you don't understand something to ask me a question about it, and I will answer. Okay?
What would be the order before there? It's the coordinates are the first two, and then there's the positions of each corner, is it?
Yeah. So the first two, what that will do is it will draw a triangle starting at 0, 0, and then over 100 and down 100 for the second vertex, and then over 50 and down 10 for the third vertex, and it will make a triangle out of them, like that. So we're specifying the 3 vertices of the triangle. So, okay. What else might we want to draw?
Square.
A square. So there's a command in processing called rect. And how many parameters would you think that takes? 8.
Probably 1, then width and length.
Okay, so we have, how many then? Either 8 or 4. It actually takes 4. Alright? So let's try the rect one. Let me try the rect one. I'll specify 10, 10, and 50, 50, and see what that does. Okay, so I get that. So, what do we think? 10, 10 is what?
Just start top left corner.
Which, there's 4 points on the rectangle. Which one is it?
Top left.
Top left.
It's going to be the top left, okay? So when we do rect, by the way, if you have a pen and paper, it's kind of handy, or if you're writing this into your computer, then just write a comment beside it. Comments in processing are the same, so just write a comment to say, this is what the 4 parameters mean, okay? So 10, 10 is the top left-hand corner. 50, 50, what do we think?
Bottom right.
Either the bottom right, or it's possibly, could be also be the
Length and width.
width and the height. How would I know? I mean, if I didn't have the processing manual, how would I figure out?
We can try it.
Test.
Yeah, well, give me some numbers to type in for the width and the height.
You could put the line below the rectangle.
Well, here's the thing, right? What if I typed in 10, 10 for these? Either of 2 things are going to happen, aren't they? If 10, 10 represents the width of the height, then what am I going to get? I'll get a square. If 10, 10 represents the coordinates, what will I get?
Error.
We'll get a dot. We almost never get an error in processing unless there's a syntax error. The program will run, but it just may not do what we want it to do. So let's run it and see what we get. So we get a little square. So what does that mean the second 2 parameters are? They're the width and the height. Alright, so I've got the first 2 parameters and the second 2 parameters. So I've got the these things and then the width and the height. Okay,
It's 2D cubes.
a 2D cube.
Yeah.
Definitely. Yeah, that'd be pretty easy. Just two squares, and then some lines that connect up the vertices of the top left and the bottom right. What's that?
No function for it.
No. There's a function for doing, there's lots of stuff for doing 3D. You know, you can specify the vertices of 3D objects, and you can set up 3D really easily. We'll build up to that, okay? So I've got ellipse, line, triangle, rect. So now we have the line drawing primitives. These are called line drawing, or these are basically the 2D primitives. Let's see what we'll do now. Yeah, let's talk about color. There are 3 ways of specifying colors in processing, right? We can specify color. In fact, there's three commands, 3 methods for doing that. Oh yeah, here's the thing. I've called these functions earlier on, but from now on we won't call them functions. We'll use the OO term for function, which is a method. Alright, so you'll hear me use that term a lot. A method. Alrighty, so we'll use methods. That's the term that we'll use. Yeah, all the time. Okay, so I've got 3. First one is this. Okay, you can pretty much straight away figure out what's that going to change the color of. We'll change the color of the background. Cool. Now, there's 2 versions of all of these color methods in processing. There's one version that takes 1 number, and then there's a version that takes 3 numbers. I think there's a version that takes 4 numbers. RGB, RGBA, or what's the one that just takes 1 number?
hexadecimals?
Sure, yeah, they're going to be hex, or you can specify them in hex. But if I just use 1 number for this background command, what's it going to do?
White to black.
It'll be white and black, basically. Yeah, so it's grayscale. Interestingly, all of the numbers that we use for this must go between 0 and 255. Why? And what's the significance of 0 to 255?
The size of a byte is...
Their size of 1 byte. Alright, so 0 to 255, how many bits does it take? 8 bits. Alright, so it's 2 to the power of 8. Did you guys do this with art last year?
Yeah.
Binary numbers and stuff? Alright, so colors are typically specified using three 1-byte numbers. And in fact, if you specify an RGB triple, how much memory does that take up in your computer's memory? 3 bytes. But computers are typically aligned on powers of 2, so usually it's 4 bytes. You know, so you'll specify RGBA. Anyway, background. Let's try this. 0. What's that going to do? A background of?
White.
Try again.
White.
Black. Okay, so 0 is black. So 0 is no color. Alright, so this is the intensity from black to white. So we can go 0, or background 255 will be all white. A background of 0 will be all black. Okay, now I've drawn that rectangle over, so I'll get rid of that. So we've got background 0, background 255, a background of 127, we'll say, which is roughly halfway through. You'll get a grey. You'll get exactly grey. So you get grayscale if you specify 1 number. The other option is to specify 3 numbers. So I could specify 0, 255, and 0. And what colour will I get then?
Green.
Why?
Ordinary number.
What's that?
It's the name number of the colors group is 0.
Yeah, exactly. So if you specify 3 numbers, then the first number is the intensity of red, the second number is the intensity of green, and the third number is the intensity of blue. So if I wanted something to be yellow, what combination makes yellow?
Green and blue.
Huh? Yeah, because somebody knows, what 2 colours do you mix to make yellow? Yeah? Is it green and blue? Red and green. Well, let's try a few. Okay, so let's try red and green and see what we get. So that's red 255, green 255, and blue 0. There we go. So you mix red and green together and you get yellow. So you can make any colour that's visible with the human eye by specifying combinations of red, green, and blue, and that's called 24-bit colour. 24-bit colour is enough to represent any colour that the human eye can recognise. And then alpha is another thing which allows you to specify transparency. So we've got background. Okay, here's a quick question for you, just to see who's paying attention.
Can we
Yeah.
back into a sheet?
You can. We'll get to that. I'm just going to show you that in a minute. I just want to show you one quick thing before I show you that, right? What would happen if I move the background code to here?
Go yellow on the screen.
Yes, the entire screen will be yellow. So what that does is it wipes the screen to whatever colour you specify. So if you do it at the start, you know, it'll wipe the screen and then draw over it. But if you do it at the end, it will do all the drawing and then wipe the screen yellow. Does everybody follow that?
Are the forms still under the yellow, or is it just completely gone?
The pixels have been wiped with the yellow color. You know what I mean? So there's nothing as such underneath. There's no layering.
But there's no virtual. Does the program not remember?
It'll still be stored.
There's no layers,
It'll still be stored there.
It's done. It doesn't actually store, layers or anything like that. What it will literally do is it just fills that particular pixel. But what's happening here is the screen is being redrawn 60 times a second. And every time it redraws the screen, what it does is it draws the screen off, without getting into too much details, it buffers them, right? But you don't see it. You'll never see it. I'll explain another time what actually happens.
Could you set it up in such a way that it would store layers?
Of course, you'd have to just write the program to do it, Definitely. So anyway, there's background. Next two commands are stroke and fill. And I guess you can have a guess. They take either one or three or four parameters as well. So we've got stroke. What do you think that's going to do?
Set the pen.
It's the pen color. So it's the color that the outline of things are drawn. So if I use background 255, and then I can do stroke 255 00, then that means my pen color is going to be what? Red. And then the fill color is the fill color for shapes that get drawn. So you can specify 0, 0, 255. So now I get red, green, and 255 for blue. I'll click the play button there, and I get that kind of nice shape there. Okay, everybody following so far? So double check to make sure this thing's switched on still. Sometimes it switches off by itself. It's cool. All right.
So if you put, say, stroke and fill after a shape, and all the shapes after that have that colour.
You got it exactly. All the shapes before that will have, like here's the thing. Say for example, I wanted to draw some shapes with the red outline. So I can do that command there, and then I can bring this command down here, and I can change this 255 to be 0, which is going to be black. Okay, so 0, 0, 0 is the same as 0. So what will happen is the ellipse gets drawn with the stroke of 255, and then the line and the triangle are going to use this command. And again, it's the idea of the sequence, that the program executes the instructions sequentially, one after another, like that. So you can't really see it too well, but you can see that the ellipse is drawn in red, and then the outside of the triangle is drawn in black. Everybody ready? Everybody happy with that? Okay, one last command. In fact, I'm wondering, will this just work? And then I don't have to do any more commands. Let me just do this. Size. There we go. So, pretty easy to figure out what size does, isn't it? What does size do? Changes the size of the palette, or the size of the what's the name? The size of the screen, the size of the window that you're basically drawing into. Is that okay? Are you guys ready to write your first processing sketch by yourselves? You can do this on pen and paper if you like, okay? I'm going to show you a couple of processing sketches, and you can choose which one to draw. You know what? I'll save that, and I'll comment it, and I'll put it on the Git repository for the course. So let me cancel that, and I'll find a little processing sketch. Okay, so here's a little processing sketch with two little shapes that you guys can draw. You can pick whichever one you want. Now, ideally, if you can sit beside somebody with a laptop. Alright, so if you don't have a laptop with you, do it on pen and paper. It's an important exercise. I want you to try and write the processing commands to draw either of those two shapes. Okay? You can pick whichever one you want. Yes! I'll pause the video.